Good morning and happy Thursday. The grades were great. Every single person made 85 or higher that took the test yesterday, so way to go on that. We are going to start kind of a new unit today, which is volume. So I bring up this slide here, this paper, to say that if we were in class, this would become your best friend for, the remaining portion of the semester, because a lot of what we're going to do here, obviously we're not going to get to all the standards. I think I might have made that clear. So like some of these things like this and this, we're not going to get to. I'm trying to pick what I think is the most important thing for geometry. Very hard to do because I feel like they're all important. However, we would have gotten to all of it in class, but we, are having to do what we can with what we've got. So we're just I'm going to show you this. I'm also going to upload it to Google Classroom so y'all can have it as a PDF. But I have like a laminated copy of these in my classroom, and I would have just handed you one every day or had you pick it up as you entered the classroom every day, because this is something you would have been able to use on the end of course test. So with that being said, you didn't have to memorize these formulas, which is super nice. Obviously with distance learning, you don't have to memorize them either because you can use them. But I just wanted to show you this is what the end of course test formula sheet looks like. And we're going to be doing volume of different solids, and so three-dimensional shapes. So you can, reference here. I'll obviously have them in the notes as well. Okay. So we're going to do three different shapes today. We're going to do the rectangular prism, a cylinder, and a cone. All right. So the first thing is, this is not on the formula sheet, the rectangular prism. So I think the reason for that is this is kind of an old one, like one you should have learned way back when, elementary and middle school. So they don't really focus on it, but I do want to bring it back up just because it is a solid like all of the other ones. Okay. So a rectangular prism, the formula is length times width times height. So it's kind of like area, which is length times width, and then you just add the height because it's three-dimensional. Okay. So it's probably the easiest. So if you look over here at the rectangular prism, we have some length of 5 meters. We have some width, and we have some height. Okay, you can switch the width and the length, depending on how you're looking at the figure or how this is kind of sitting on the table or whatever, as you see it. So literally you just take them and you multiply them. So we're going to do 2 times 5 times 4. And then 2 times 5 is 10. 10 times 4 is 40. Now, we are having meters, meters, meters. So it's a meter times a meter times a meter. So how many meters is that? That's 3, right? So that's meters cubed. So whenever you're doing volume, you're going to be cubed. Okay? And if you remember with area was squared. Okay? Units. All right, that's as easy as it is. Now, the next one says find the volume of a cube. So a cube is technically still a rectangular prism, but what is different about a cube is that it's basically all squares. The faces are all squares as opposed to rectangles. So when I only give you one length of 7 inches, you can still say 7, 7, and 7 here. Okay, so the length is 7, the width is 7, the height is 7, okay? And then 7 cubed, or 7 times 7 times 7, is 343. And what was our unit here? Inches cubed. So hopefully rectangular prism and cube, since they're kind of the same thing, they're going to be the easiest for you. All right, so next is a cylinder. A cylinder, I think of like a Pringles can or a canned good on your pantry shelf, or like a Coke can, any of those types of things. I think Pringles is probably the best example. Most of us know exactly what that looks like. So a Pringles can is a cylinder. A hockey puck is actually a cylinder as well. It's just a really short, like squatty cylinder. So we can have lots of real world examples of these. But a cylinder is this formula right here, pi r squared h. Now, we bring pi in whenever there is a circle involved. So do we agree that a cylinder is basically a circle, and then you just keep stacking, so it starts as a circle, and then you just keep stacking them up, all the circles up. So it's the area of a circle, essentially, which is pi r squared, and then its height. Okay? So the formula pi r squared is the pi r comes from the area of one circle, which is like the base, this part, and then you just times it by the height, because that's basically you just keep stacking that circle all the way up. Okay, now that doesn't make sense. It's okay. You can just plug into the formula. We are going to leave pi in the answer instead of multiplying it unless I tell you otherwise. Okay, so we'll just leave pi as the symbol because it'll kind of quote unquote look nicer. We'll see. And then y'all know R stands for radius, H stands for height. Okay, so maybe let's write that in just to remind us. So radius is R and H is height. Okay. All right, so let's fill in this formula. So our radius is 5 inches, our height is 7 inches, so we have enough. So volume is pi r squared. That means we're only squaring the 5, and then the height is 7. All right, so then we're just going to type this part in right here. So we're going to type in 5 squared, which is 25, times 7. And you don't even have to do the 25 in your head. You can literally just type it in. 5 squared, which is what I did in my handheld calculator, times 7, which is 175. But then we have to remember to bring the pi down, and then we need our units. So inches cubed. Okay. All right. So now let's look at the next one. I am going to try to throw in some tricks every now and then, so y'all kind of be on the lookout. With this next one, this cylinder is on its side, so this is the height. It's just, think about the Pringles can lying down on your table or counter or whatever. Now, the 15 is the diameter as opposed to the radius. So we do not want the 15. How do we go from diameter to radius? Well, if we have the diameter, all you have to do is divide it by 2. So diameter divided by 2 equals the radius. Okay, so we're going to do 15 divided by 2 to equal the radius, and 15 divided by 2 is 7.5. Okay, and so now we can fill in our formula. So we have volume equals pi r squared, and then the height is 22. And so I'm just going to type this in. I'm opening my parentheses. I'm typing 7.5 squared. I'm literally typing it like I see it, and then times 22. And you get a decimal. That's okay. 1,237.5 pi feet squared. So I'm doing this in the calculator. That goes for there. Then our pi comes down, and then feet. Oops, I said squared. My bad. That is not correct. It should be feet cubed. I'm glad I looked at it again. All right, so there really aren't any tricks for the the rectangular prism or the cylinder, except for the fact that I could give you the diameter as opposed to the radius. Okay, so just be on the lookout for that. So that's those two. Sometimes the cylinder might be lying on its side, so you can be on the lookout for that. All right, so a cone is the next one. I think of literally like an ice cream cone, or like pelicans, or what are those? The snow cones, the cups that you use. I also play golf, and so when I go to the golf course, when I used to go to the golf course and I would get water, they would have like these little cups that are in the shape of cones that I would pull and use to get a sip of water from the cooler. So I don't know if you think of that. You can also think of like a traffic cone. So there's a lot of real world examples of cones. Now, I want you to look at the formula of the cone versus the formula of the cylinder. Do y'all see that basically these two things are the same, except for cone has the 1/3 out front? And here's why. Now, y'all know I'm not a good drawer, but it basically is saying we could fit 3 of these cones and make a cylinder. So if you can envision the point going here, and then the point going here. Ooh. So obviously that's not really the best drawing, but you could fit 3 cones in and it'll make a cylinder. Okay. If Mr. Thomas were here, they're outside, so he could help draw it, but we'll just go with it. So anyways, that's why they're related to each other, is because a cone is basically a third of the volume of a cylinder. Okay? All right, so we're going to do radius is here, height is here, and so we have enough for our formula. So let's plug it in. Volume equals 1/3 pi, and then r squared, and then the height is 22. All right, so let me show you how I'm going to do this. I'm still going to type this part first, okay? So I'm going to do 8 squared times 22. I should have been doing this in Desmos, but that's okay. I think y'all can follow along. And then I'm going to bring the 3 over. Now, I want y'all to understand, this is like let me rewrite this. Volume equals 1/3 pi 8 squared 22. Do y'all see how that looks a little better? And you can keep this fraction going. So everything on the numerator equals this. And then the 3 comes over. Now I want to see if those can be divided nicely. So when I type in 1,408 divided by 3, it does not work out as a nice whole number. It's like 469.3 repeating. So I'm just going to leave it like this. Okay, now I don't care if you put 469.3 repeating, but I just think this looks a little bit better. And then our units are centimeters cubed. Okay. All right, so that's a straightforward one. Let's see how I can trick you a little bit more. Okay, so on number 6, it's a cone still, but how have I tricked you in this problem? Well, I have given you the height. Instead of giving you the radius, I've given you the diameter. So remember, you take the diameter and you divide it by 2 to equal the radius. So 8 divided by 2 is 4. So everybody see that that would be your radius. Okay? All right, so now I think we have enough. So volume equals 1/3 pi r squared and our height. So I'm going to keep this fraction going. All right, so that's going to be 4 squared. Okay, so 1, I'm not really doing 1 times because 1 times anything gives you that number. So I'm just kind of ignoring the 1. I'm doing 4 squared, which is 16 times 10. So that's 160 pi. And then I'm bringing my 3 over. I'm going to type in my calculator 160 divided by 3. And again, it's a repeating decimal. So I'm just going to leave it like this. Now, if you wanted to write 53.3 repeating, you could. I just think, again, this looks a little bit better. Okay? So do y'all see how I just made that just a tiny bit harder by, instead of giving you the radius, I had to give you the diameter. So you had to just do a little bit of thinking. Okay? And then number 7 is the one that y'all need to put a really big star by. It's the trick question. And so I want y'all to look at it really quickly. So first of all, I gave you the diameter, so we want the radius instead. So the radius, half of 16 is 8. All right. However, a lot of students are going to want to say that as the height. But what is wrong with that height right there? The problem with that height is it is slanted. Do we go to the doctor's office and get measured slanted? No, those nurses and doctors would, not have their job still probably if that's how they measured, and they don't. So we have to draw in the height. Okay? And so now I want you to notice what kind of angle does that make right there? Makes a right angle. And then what do you notice about this shape right here? From here to here to here. Well, that is a right triangle. And we have been talking about those. So hopefully this kind of rings a bell. So I'm going to draw it with a different color. I'm going to come up here and I'm going to go. Okay, so this is our height. This is 17. And how much is this? Now we're tempted to put 16, but remember it's only the radius. So we're only going from here to here to here. So it's the 8 as opposed to the 16. And now how do we solve that type of problem? Well, we're going to do Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. And the reason this is a trick is because a lot of students are going to want to say the 17 is the height, but it is not. So we have to do Pythagorean theorem to find the height. So we're going to go 8 squared plus b squared equals 17 squared. Remember, the hypotenuse always has to be the c. So that's 64 plus b squared equals 289. And then what do we do with that 64? We subtract it. So b squared equals 225. And yay for us, that is a perfect square. So if you take the square root of 225, you get 15. And so now that is our height. Okay? So that's the trick you need to look out for. That's really the way I could try to make it a little more challenging for you. So be on the lookout for that. All right, so now let's finish the problem. So volume equals 1/3 pi. Our radius is 8 squared, and our height is now 15. So I'm going to type in 8 squared times 15. I get 960. I'm going to bring my pi over and my 3. Now I'm going to divide it and see if it comes out nicely. And it does this time, finally. So I'm actually not going to leave it like that. I'm going to divide it. So I'm going to divide 960 by 3, and I get 320. Okay, so that's 3 shapes with kind of starting with your basic shape of a rectangular prism or a cube. Then we went to a cylinder, and then we went to a cone, which kind of has the trick question with the slant height. Okay, so I want you to try these 3 problems here at the end. It's one of each, like what we just did a minute ago. I did not give you units on 1 and 3, so just put like u cubed, and the name is like, I just want you to tell me what the name of the shape is, the figure, just because that helps us practice as it gets a little more challenging. All right, good luck with those 3. Let me know if you have any questions, and have a great day.